Algebra 2, Chapter 5, Section 3. So these are the two sections we're going to cover before you have a little quest, kind of quiz and test together. Some review. Leading coefficients we've talked about in math for a while now. We should realize the leading coefficient is the coefficient that's being multiplied to the variable with the biggest degree, so the biggest exponent. So 5 would be the leading coefficient. What degree is the polynomial? The degree of the polynomial is not the first exponent, it's the largest exponent here. So this is degree 4. So that's what we're talking about today is polynomials, and we do some operations with polynomials. To review, the polynomial is many monomials. So the sum of terms in the form of ax to the k power. And so you can have any sum adding and subtracting of monomials, where each of these would be a monomial. So this would be 3 monomials, so this would be a 3-term or a trinomial. Standard form for these polynomials is always put the exponents in descending order. And so you can see if this problem here is not have descending order of exponents, you want to write it in blue here. We have the x to the fifth, x squared, and x. That would be standard form. The degree of the polynomial is the exponent of the variable is the degree. So this would be 4x to the 8th is degree 8 is the 8th degree. The degree of the polynomial is the largest degree of any of its terms. If you have more than one variable, you'd actually add the exponents to figure out what the power would be, the degree would be. For this one, the degree of this polynomial is x to the 5th, so it's a 5th degree. The leading coefficient, again, is the number in front of the first term when it's written in standard form. So a monomial is a 1-term polynomial. Binomial, bi is 2, so a 2-term. And then we have a trinomial, tri 3, so we have a 3-term. These are some of the common names we'll talk about. Anything more than that, we usually just call a polynomial, so a mini-term. So an example here of adding polynomials, subtract or add them, all you do is you combine like terms. And so there's two ways we can use like a horizontal format here where you have to find like terms. And like terms not only have to have the same variable, they have to have the same degree. So here, these two are x to the 3rd. And so we can just horizontally do it. This would be x squared, and we have x squared over here. And so I'm just grouping together like terms. These are single x's. We have x to the 5th. That's only x to the 5th. And we have constants and x to the 4th. And then you can actually combine them by taking the number in front. So -3 and 7 would be 4. So 4x cubed. And then you can continue on with all of them. So that'd be plus 23x squared. I'm just finding the like terms and adding the like terms, the coefficients. The x's are gone, -8x and 8x is positive is 0. And then x to the 5th, those are only x to the 5th. We have a -2x to the 4th, did not have any like terms for that. And we have a +2 and a -3, which is -1. And we could write this in standard form. I want to do that same problem again for you, but I want to show you how for a lot of students they actually like to do it vertically. So vertically is when you write them, instead of writing them left to right, we can write them in order in standard form, and when we write the second one, we would write it below the like terms. So when I write the second one, 8x, I would write below the -8x because they're like terms. -2x to the 4th, we don't have another term like that. I might squeeze it in here so it would be in standard form. 7x cubed, put it below the x to the 3rd. -3 is a constant, and then 12x squared. So now vertically I have the columns set up, so now I can combine like terms. This would be x to the 5th, -2x to the 4th. And so now I can look here at this column and then combine like terms to get the 4x cubed. plus 23x squared, and then we have the 0x and then minus 1. So vertically it helps you organize the work a little bit, which might help some of those basic math mental errors that have been we've been getting caught up with. So when we subtract these polynomials, or writing the terms down, we can leave spaces for terms we do not have. So we don't have an x squared term, so we leave a space for those terms in case we have them in the following polynomials, which we do here. We're going to subtract a negative x to the fourth. Then we have a minus x squared plus 2x plus 8. So now vertically, when we look at this, we can subtract the vertical like terms. We can also add the opposite, which tends to help people with basic math or the signs. So now it's going to be 11x to the fourth plus a positive x to the fourth, so it becomes 12x to the fourth. Then we have the positive x to the third. This is now a positive x squared, and it became positive because we were minusing a negative, so we're positive now. And we have a negative 3x, and then a negative 3. So there's the polynomial. We cannot combine like terms. So we're multiplying polynomials. Now we're changing operations. When you multiply, it's like the distributive property, but you're distributing more than one term. So we're distributing this first term to everything in the second polynomial. And then we do that again for the 7. We distribute the 7 through the entire second polynomial. And you multiply every term together, and then we combine like terms. So if we do that, we'd have x times 5x is 5x cubed. X times x squared is x cubed. We do x times 4x, we get plus 4x squared. And we have x times 3 is 3x. So you can see the importance of the exponent rules when you multiply. We're going to repeat that process here with the 7. So 7 times 5x squared is 35x squared. And when you write that, you need to write it below the x squared terms to keep yourself organized. We have plus 28x plus 21. So now we can add our columns together, add our like terms. So we have 5x cubed plus 39x squared plus 31x plus 21. So then make sure we have all like terms combined. We do, so we are done. This is called the extended distributive property. We start multiplying polynomials together. Another method of multiplying is to use kind of a framework here. These boxes, tic-tac-toe some people call it, but if we have a trinomial times trinomial, it gets kind of messy, so sometimes we'll put those trinomials here in the rows and columns. So the column here is the first trinomial, the x squared minus 2x plus 2, and then the row here is the second trinomial. And then you multiply each row by column. So this would be x squared times x squared is x to the fourth. And x squared times 2x, it'd be 2x cubed. And we have 2x squared. And so then these boxes kind of help you with your organization of your work. Some students like this method. Watch your exponents. And when you're done, the nice thing about this is it is easy to see your like terms. A lot of times, not all the time, but these diagonals, we look at the degrees of these, they have the same degree. And so those are your like terms. So if I combine them, I have x to the fourth, I have minus 2x cubed plus 2x cubed, which is 0. Then I have, these are also 0, and then these are 0. So I actually end up with x to the fourth plus 4. That's another way of multiplying polynomials. Another kind of way, which is FOIL, you've probably seen this in the past, it's first, outer, inner, last. So the first term in each of the binomials is multiplied. So that's m squared. Then you have the outer, so the outermost terms, which would be 2m. Then you have the innermost two terms, 4m. And then you have the last two terms in each binomial. And then we can combine like terms. So we have m squared plus 6m plus 8. So this is FOIL. FOIL is really important. We're going to do a lot of that using it backwards for what's called factoring. There's some patterns that occur here. So some of these special products. So if we have a plus b times a minus b, notice how those are the same binomials, just opposite sign. The result is always this, a squared minus b squared. That's called the difference of perfect squares. A squared and b squared are perfect squares. So example of that, 3x minus 4 and times 3x plus 4 would just be 9x squared minus 4 squared. You square each term and have a subtraction between them. The other kind of special product is when you're squaring a binomial, and that can be expanded. So the a plus b squared or a minus b squared always gets expanded to this format, which isn't big if you to memorize, because you can always write this as a plus b times a plus b, and that's why I suggest students writing that out. If you have a plus b squared, first rewrite that as a plus b times a plus b, and then you can just use FOIL, and then you don't have to memorize this pattern, but it's not a hard pattern to know or to become comfortable with. But x plus 4 squared would be x squared plus 8x plus 16. The pattern is you double the constant or the second value to get the 8, and then you square it to get the last term. So following that pattern, 2x minus 6 squared, I get 4x squared minus 24x plus 36, which is a little different because this 2 affects that value. And that 2 is seen in the a times b in the pattern. So you have to do 6 times 2 and then double it to get the 24. And here's not as big, so it's 4 times 1, and then you double it. So the 4 times 2 would be the 8. So a few more examples here. Find the product of 9w plus 3 times 9w minus 3. You need to recognize that that's a difference per squares, which was this pattern. So you square each term and put the minus between them. And so I'd have the quantity 9w squared minus 3 squared. And I can simplify that. This is 81w squared minus 9. We can apply that property here, these as well, the shortcuts. So I know that this is going to be 144x squared, and at the end I know I'm going to have 16. I tend to start with the first term and the last term just by squaring each of these. The middle term here is me doubling these two multiplied together. So if I multiply them together, I get 48. If I double that, I get 96, and then I still have an x. So that's applying the pattern. Again, if you don't see the pattern, you can expand it as the two quantities, and then you can just FOIL. So if I'm FOILing this again, the first would be 9k squared, and here's the pattern. I FOIL a little different. I would do the first and then I actually do the last, which would be positive 4m squared. So I put the first term first, the last term's last, and then I have to find the middle. And I do something different here. I do what I call OI. OI is the outers plus the inners. The O and the I. The O and the I, which make up that middle term. So the OI is negative 6mk. The middle one is negative 6mk. So if I add them, I get negative 12mk. So that would be the trinomial for that. So I'm going to have you do these two special products, whether you're using the pattern or you're just foiling them. Either way is fine, but we got to be able to do these quickly, not just correct. We got to be really fast at these, because we'll actually end up doing the opposite direction in future sections.